Rome's aqueducts were built by an empire obsessed with control, yet Frontinus, the man in charge of Rome's water supply, spent most of his career fighting people who illegally tapped into the pipes for free. Tesla built its supercharger network as a closed, proprietary moat, deliberately locking everyone else out, and then, at the height of its advantage, voluntarily tore the walls down and gave the design away. One system fought to stay open. One system chose to stop being closed. Same infrastructure problem, opposite instincts, and, weirdly, the same underlying logic. Let's dig into why. In 97 AD, a Roman senator named Sextus Julius Frontinus took a job most people would have avoided. He became curator aquarum, the man responsible for every drop of water flowing into Rome. What he found was not a clean, orderly system. He found theft. Farmers and landowners along the aqueduct routes had been secretly drilling into the channels, running illegal pipes off the main supply to water their own fields. Rome's officials called it puncturing. Every illegal tap meant less water pressure for the city, less water for the public fountains, less water for the people who were actually paying for it. This was not a small problem. Water in Rome was not just a convenience. It decided whether the baths stayed open, whether the grain mills kept turning, whether the city stayed calm or grew restless. A network that could be quietly drained by anyone with a shovel was a network that could not be trusted. And that is the real problem this video is about. Not how to move water or electricity from one place to another. That part is just engineering. The harder problem is this. How do you get thousands of strangers to share the same system, without some of them quietly taking more than their share or breaking it for everyone else? Rome had to answer that question with stone and law. Almost 2,000 years later, a very different kind of organization would have to answer it too. Solving this problem started long before Frontinus ever took office. It started with a much more basic question. How do you move water across 50 kilometers of hills, valleys, and forests using nothing but gravity? Roman engineers had no pumps, no engines, no electricity. The only force available to them was the natural pull of water downhill. That meant every aqueduct had to be built on an almost impossibly precise slope. Too steep, and the rushing water would tear apart the channel walls. Too flat, and the water would slow down, stagnate, and eventually stop moving altogether. The numbers involved are hard to believe even today. The aqueduct feeding the Pont du Gard in southern France drops only 17 meters in elevation over its entire 50-kilometer length. That works out to a slope of roughly 1 in 3,000, shallower than a modern wheelchair ramp, held steady across tens of kilometers of uneven terrain. The Aqua Claudia, completed in 52 AD, was engineered even more gently, dropping about 1 meter for every 258 meters it traveled. To hold that gradient across land that offered no natural cooperation, Roman engineers used whatever the terrain demanded. On flat or gentle ground, they buried the channel underground, protecting it and keeping the slope steady. Where hills blocked the path, they cut tunnels straight through solid rock. Only where a valley or depression truly could not be avoided did they build the towering stone arcades that most people picture when they think of Roman aqueducts. Those arches were the last resort, not the first choice, because they were expensive, difficult to build, and required precise engineering just to keep their arches aligned over long distances. But getting the water into Rome was only half the job. The other half was making sure it was shared fairly once it arrived. This is where Frontinus made his most lasting contribution. He documented 25 standardized sizes of bronze nozzles, called calyxes, which controlled exactly how much water any household, farm, or public fountain was legally allowed to draw. Flow was measured in a unit called the quinaria, turning water into something that could be tracked, taxed, and audited, rather than something anyone could simply take. And standards only work if someone enforces them. Frontinus oversaw a staff of hundreds of workers whose job was to inspect the aqueducts, repair damage, and catch illegal taps before they spread. Tampering with the system was treated as a serious crime, punishable by heavy fines, because the water technically belonged to the emperor himself. Rome's solution, in the end, was never just an engineering marvel. It was engineering paired with law, and law backed by enforcement. Take any one of those three away, and the whole system would have failed. Almost 2,000 years later, a company called Tesla ran into a strikingly similar problem. just with a different resource. Instead of water, it was electricity. Instead of an aqueduct, it needed a nationwide network of charging stations. And instead of inheriting an empire's infrastructure, it had to build everything from nothing in barely a decade. In 2012, when Tesla released the Model S, there was no shared charging standard in the United States. Different companies were experimenting with different plugs, different speeds, and different levels of reliability. Tesla's answer was to build its own connector, called the Tesla Charging Connector, and pair it with its own network of fast charging stations, called Superchargers. Both the plug and the network were closed. Only Tesla vehicles could use them. At the time, this closed system was not a weakness. It was the point. By controlling both the hardware and the charging stations, Tesla could guarantee a consistent experience everywhere its cars went, while competitors were left fragmented across incompatible standards like CCS and CHAdeMO. A driver who bought a Tesla knew exactly what to expect at every station, because Tesla controlled every part of the chain. For nearly a decade, that stayed the strategy. Then, starting in 2022, Tesla made an unexpected move. It opened its connector design to other manufacturers. In 2023, SAE International, the organization that sets engineering standards for the auto industry, formally adopted Tesla's design as an official standard, now called NACS, or the North American Charging Standard. Within about a year, most major automakers, including Ford, General Motors, Hyundai, and Kia, announced plans to adopt it for their own vehicles. This was a significant reversal. Tesla was giving up the very exclusivity that had made its network valuable in the first place. But the reasoning was not really a change in strategy. It was the next stage of the same strategy. Tesla's supercharger network had already built a reputation as more reliable and more extensive than any competitors. That reputation had become a genuine selling point, pulling customers toward Tesla and away from other electric vehicle brands. By opening the network, Tesla was not giving away its advantage. It was converting a private advantage into an industry standard, one that other companies would now have to build around, rather than compete against. The result speaks for itself. Tesla superchargers now account for close to 75% of all fast-charging infrastructure in the United States. The network that started as a closed, single-brand system became the backbone that the rest of the industry now depends on. What makes this worth pausing on is the order of operations. Tesla did not open its network first and hope reliability would follow. It built a closed, tightly controlled system, proved that system worked at scale, and only then opened it up. Reliability came before openness, not after it. Strip away the stone and the copper wire, and these two systems start to look a lot more alike than they first appear. Every large-scale infrastructure system, whether it's built from marble or silicon, seems to need the same three layers to actually function. First, a physical delivery mechanism. For Rome, that was a gravity-fed channel engineered down to fractions of a percent in slope. For Tesla, it was a network of high-voltage charging cables and stations. Second, a standardized interface. Rome's 25 sizes of bronze calyxes, controlling exactly how much water any single user could draw. Tesla's single NACS connector, replacing what had been a chaotic mix of incompatible plugs. And third, a governance and enforcement layer. Frontinus and his staff of inspectors hunting down illegal taps, backed by serious legal penalties, compared to SAE International's formal standardization process and Tesla's own rules for network access. Take any one of those three layers away, and the whole system breaks down in a predictable way. No standardized interface, and the network fragments into incompatible pieces that can't serve everyone. No enforcement, and the system gets quietly drained by people taking more than their share. No physical mechanism, and there's no network at all, just a plan on paper. Once you see the systems this way, the similarities start piling up. Both started small and closed before they scaled. Rome's very first aqueduct, the Aqua Appia, was built in 312 BC to serve a much smaller city than the one Frontinus would later manage. Tesla's supercharger network started as a system exclusively for one company's cars. Both needed a standardized unit of exchange before they could function fairly at scale. Rome's Quinaria, Tesla's NACS connector. Both treated unauthorized use as a real threat, not a minor annoyance, and built enforcement systems to catch it. whether that meant Roman inspectors patrolling aqueduct routes or Tesla restricting supercharger access to its own vehicles for nearly a decade. And both eventually chose to expand access rather than keep the system permanently closed. Rome extended aqueducts to cities across the empire under imperial funding, while Tesla opened its connector to competitors. But the comparison has real limits, and forcing them to match perfectly would miss what's actually interesting about the differences. Rome's aqueducts were state property. Tampering with them was a crime against the emperor himself. Tesla's network was private capital, and opening it up was a business decision, not a legal obligation. The motivations were different too. Rome standardized water access mainly to keep taxation fair and to maintain political stability across a vast empire. Tesla standardized its connector mainly to convert an early advantage into long-term industry dominance. The timelines were nowhere close to comparable. Roman aqueduct engineering barely changed for centuries at a time. Tesla's entire shift from closed connector to industry standard happened within about a decade. And the two systems fail in very different ways. Roman aqueducts declined slowly through physical decay and the gradual collapse of the political structures that maintained them. A modern charging network is more likely to fail quickly through congestion, software problems, or shifting regulations. So why do two systems, separated by 2,000 years and built for completely different reasons, end up with such a similar underlying shape? The likely answer is that any resource distribution network, once it grows past a small group of people who already trust each other, runs into the same basic requirements. It needs a way to physically deliver the resource. It needs an agreed-upon standard so that the resource can be measured, shared, and used consistently by strangers who have never met. And it needs some way to make cheating costly, or the whole system slowly gets hollowed out from the inside. This is also why opening a system too early tends to backfire. Without a period of closed, high-reliability testing first, an open network is more likely to fragment into low-trust, incompatible pieces, which is close to what happened across the American electric vehicle charging landscape before NACS became the standard, which points to something bigger than either water or electricity. Infrastructure is rarely just an engineering problem. Underneath the concrete, the wiring, and the technical specifications, it's a problem of trust, getting a large group of self-interested people to rely on the same system without hoarding it, damaging it, or splintering it into competing versions. That same underlying shape shows up far beyond Rome and Tesla, in systems like electrical grids, internet protocols, and even something as basic as a shared currency. All of them had to pass through the same rough sequence. Build something closed enough to prove it works, agree on a shared standard, and enforce it well enough that people stop thinking about it at all. So next time you plug in a phone, fill up a tank, or just turn on a tap without thinking twice. That invisible ease is the result of someone, somewhere, solving this exact same trust problem. Which makes me curious. What's a piece of infrastructure you rely on every day that you think is quietly running the same closed-to-open playbook Rome and Tesla did? Drop it in the comments. I'll read through and reply to the best ones.